Hi, my name is Ramasu. Welcome to my presentation on question 8 from the 2008 BGCSE Science Double Award, Paper 2. The question says that dry chlorine can be prepared in the lab as shown in figure 8.1. Okay, there's the arrangement. Then part A says state the color of chlorine gas. Well, chlorine gas is yellow-green. Chlorine gas is yellow-green. That's a picture of chlorine gas in a round-bottomed flask. Okay, so part two says suggest the purpose of water and concentrated sulfuric acid in the setup. Well, the water is there to dissolve fumes of hydrochloric acid, or remove fumes of hydrochloric acid. Wrong spelling. Hydrochloric acid, right? Because there's some this concentrated hydrochloric acid will some of the fumes will go into the delivery tube and into the water, right? The concentrated sulfuric acid. Concentrated sulfuric acid is a drying agent or a dehydrating agent. So its purpose there is to remove water vapor. Because we have a test tube of water here. The chlorine is being bubbled through water, so yeah, some of the chlorine that goes through might still have some water vapor. So you have some concentrated sulfuric acid there to remove the water vapor. Part 3 says what property of chlorine makes it possible to be collected as shown. Well, chlorine is denser than air. All right. So this method is called upward displacement of air. So because the chlorine is going down, right? But the air in the test tube there is being pushed upwards while the chlorine is going down. So that's why this method is called upward displacement of air, because air is being displaced upwards. Okay. So part B says the equation for the reaction between manganese 4 oxide and concentrated hydrochloric acid is shown. Complete the equation by balancing it and writing the missing state symbols. Well, we can see from the diagram here that manganese 4 oxide is a solid. So we put S there for solid. Then hydrochloric acid is aqueous, as we can see from here. It's in a solution form, so it's aqueous. And the manganese chloride is also in solution form, so it's aqueous. H2O is liquid, it's water. And the chlorine gas is well, I guess Now to balance the to balance this out, we need to make sure that the number of particles of a particular element on the left side equals the number of the same element on the left side of the equation. Now we have Cl2 here, so we have two chlorine particles, but we only have one chlorine particle on this side. So what we do is that we put a 2 in front of HCl. So then we have two chlorine particles on the left side and two chlorine particles on the right side, right? And hydrogen, we have two hydrogen particles on the left side and two hydrogen particles on the right side. Oh no, in fact we have 4 chlorine particles. There are 4 of them, so we should put a 4 here instead of a 2. We put a 4 here, right? So then we have 4 hydrogen particles. We have 4 hydrogen particles, so we should put a 2 here, such that we have 4 hydrogen particles on this side as well. And then we have two oxygen particles on the left side. Then we have 2 oxygen particles on this side too, because we have O here and then we have a 2 at the front of H2O. So this means that 2 oxygen particles, right? So then the equation balances out. We have 1 manganese particle, we have 1 manganese particle on the right side. Yeah, so everything balances out then. Part 2 says during the reaction 8.7 grams of manganese 4 oxide reacts with the acid. Calculate the number of moles in 8.7 grams of manganese 4 oxide. Use the periodic table. Yeah, okay. So the formula for number of moles of a compound is mass of the compound divided by the molar mass, right? Now to the molar mass is the same as the relative molecular mass. So to calculate the relative molecular mass, we need to find the relative atomic mass of manganese, which is 55. It is 55 there, and of oxygen, which is 16. Right. So we have a relative molecular mass of manganese 4 oxide, MnO2, 55 plus 16, but because it's O2, so it's 16 times 2. This gives you 87. So then this becomes 8.7 over 87. This gives you 0.1 mole. So then we have 0.1 mole of manganese 4 oxide. Part 3 says use the equation in your answer to calculate the number of moles of the acid that reacted with that 8.7 grams of manganese 4 oxide. Number of moles of the acid that reacted. Okay, so we can see from this equation that 1 mole of manganese 4 oxide reacts with 4 moles of hydrochloric acid, right? So 1 mole of manganese 4 oxide reacts with 4 moles of hydrochloric acid. So how many moles of hydrochloric acid will 0.1 moles of manganese 4 oxide react with? Right, 1 mole of manganese 4 oxide reacts with 4 moles of hydrochloric acid. So 0.1 moles of manganese 4 oxide reacts with how many moles of hydrochloric acid? So the answer, so we cross multiply, and then we get our x to be 0.1 times 4. This gives you 0.4 moles. So we have 0.4 moles of hydrochloric acid reacting with 0.1 moles of manganese 4 oxide. Then part C says state one use of chlorine. Well, chlorine is used. It can be used in detergents, in cleaning detergents. It can be, let's just say bleaching detergents. It can be used in bleaching detergents. Can be used in paint and dyes. Can be used for making paper. Part D says that chlorine gas can also be produced from concentrated sodium chloride. Name the process used to obtain chlorine gas from concentrated sodium chloride solution. Well, you use electrolysis. Electrolysis is the process used to obtain chlorine gas from concentrated sodium chloride solution. Then a source for concentrated sodium chloride is mining. You can mine this as you can mine sodium chloride as it is done at SOA and SOA pen mining, and you can get sodium chloride from the ocean as well, ocean or sea. So that's the end of the video. My name is Ramasu. Thank you for watching. You can find me on Facebook, or you can follow my Facebook page, which is GCSE tutorial videos. If you need help or if you need more videos. Thank you for watching, and see you in the next video.